Hello dear friends, welcome to the lecture of real analysis. In this lecture, we shall study some multiple choice questions on real analysis and particularly on the topics functions, sequences and series of real numbers. Here I have written a few questions and we have to choose the correct alternative for each question. There are four choices and we have to select the correct. So, I will suggest you to note, observe these questions, study these questions, pause the video, study these questions and note down your answers first, and then you can check the answers afterwards when we explain these. The first question is, if S is the universal set and this is chi is the characteristic function, then chi on x is, chi of S is, what is the value of this? We know the characteristic function, if A is subset of S, then the characteristic function chi A of x has two values, that is 1 if x belongs to A and 0 if x does not belongs to A. Only two alternatives are there for this chi function's value, either 1 or 0. It is 1 when x belongs to A and 0 when x does not belongs to A. But here S is the universal set, and if you consider this function chi on S, that is chi of S, and that will be x always belongs to S because it is the universal set. Every element belongs to the universal set and therefore it is 1 because x belongs to S, and thus the correct alternative is 1. So, this is the answer for the first. Now, the second is the sequence. The sequence log of 1 by n as n takes values 1 to infinity is convergent or converges. The sequence converges, or the second alternative is diverges to infinity. Third is diverges to minus infinity, and next is oscillates. So, what about this sequence log of 1 by n as n tends to infinity? So, if you consider the limit, now we have discussed the first question, I shall rub it, and here see we know the limit of 1 by n as n tends to infinity is 0. So, this limit is 0. That means when the n becomes large and large, or n tends to infinity, this term is going to be 0. And we know as log of 0 approaches to minus infinity, or log 0 is minus infinity. Why? Because we have e to the power minus infinity is equal to 0. E to the power minus infinity means 1 over e power infinity. 1 over infinity will approach towards 0, and therefore, so by definition of logarithm, this gives, or this implies, log of 0 to the base e is equal to minus infinity, and therefore this sequence diverges to, because it is going to be 0, log of 0 when 1 by n as n tends to infinity is 0, and therefore log 0, and that is divergent to minus infinity. Log 0 is minus infinity, therefore the sequence diverges to minus infinity. Next is, if 0 is less than x is less than 1, then sigma x power n converges to which value? So, this is a geometric sequence, and we have studied a theorem on it, theorem on the geometric sequence, and that says that this sequence, geometric sequence, is convergent when x is between 0 and 1, and if x is greater than or equal to 1, it is divergent. So, but converges to which value? When see, this is the Sn of this will be 1 plus first term will be 1, x power 0, 1 plus x plus and so on, x square, etc. x power n, or if you consider nth term, then this is equal to, it is a sum of first n plus 1 geometric terms, and that is the value will be, first term is 1 and then 1 minus x power n divided by 1 minus x, and limit of this, see this or if it is n x power n, actually there are n plus 1 terms and therefore this may be taken as n plus 1, and if you take the limit of Sn, so this is Sn and limit of Sn as n tends to infinity will be equal to, and we know if x is less than 1 or x is between 0 and 1, then limit of x power n plus 1 will be 0, and therefore this will be 1 minus 0 divided by 1 minus x. So actually this is a formula for sum of first n terms of a geometric progression, and therefore this is, we have studied this as a theorem, and therefore the limit of this sequence is 1 upon 1 minus x, and therefore this geometric series, not sequence but the series, converges to 1 upon 1 minus x. So this is the correct alternative. Now fx is equal to x square and x is between minus infinity to plus infinity. Then f inverse of 7 is, the function is fx is equal to x square. Fx is equal to x square, and we may suppose this is y. Then what will be x? If y is equal to x square, then x will be equal to root of y, and it will have two signs, plus or minus, when we take the root. So x is equal to root y plus or minus root y, and therefore f inverse of x will be equal to, if you write this in terms of x is f inverse of y. So therefore f inverse of y is equal to plus minus root y, or f inverse of x is plus minus root x, and that's why, so it is a square function, its inverse is square root function, and but square root has two signs, plus or minus, because root x plus root x square is again x, and minus root x square is again x. So f inverse of 7 will be plus or minus root 7, or it has two values, root 7, or that means root 7 and minus of root 7. So this is only these values is not the correct inverse, but this will be the correct alternative. The next is, if B is an infinite subset of the countable set A, then B is uncountable, countable, equivalent to A, or none of this. Now see, B is an infinite subset. A subset of countable set, there is a result. A subset of countable set is again countable, and therefore the answer is countable. Our correct alternative is B, countable. Now the next is limit of 1 plus 2 by n power n. That can be evaluated like this. So we can write limit for this sixth problem, limit n tends to infinity 1 plus 2 by n power n. So this can be written as limit n tends to infinity 1 plus 2 by n to the power. We take the reciprocal of this to express in a particular form, 2 by n, it is n by 2, and then but the original power is n, so therefore we can write the whole expression in bracket and raise the power to 2. So this 2 and half will cancel and the original power will be the same, but this limit we know is e, the bracket is e, and therefore it is e square, because we have are using this theorem. We have proved this theorem, the limit of this sequence is equal to e, and therefore it is in the same form. Instead of 1 by n, it is 2 by n, but the power must be the reciprocal of this. 1 by n, it is n. If it is 2 by n, it is n by 2. If it is 3 by n, etc., it will be n by 3. Then same form will be there. Reciprocal of the first term must be 1, and the reciprocal of the second term must be the power, and this denominator must tend to infinity. Then the value of the limit is e, and therefore here the limit is e square. The alternative is B. The next is the series 1 minus 1 half, 1 minus 1 half plus 1 by 4 minus 1 by 8, etc. is divergent, convergent, oscillatory, or none of this. Actually, this is alternating series, and there is a theorem on convergence of alternating series. So that has two conditions. First is A1 is greater than or equal to A2 is greater than or equal to A3, and so on. That means the sequence is here non-increasing, or actually it is decreasing. And second is limit of an as n tends to infinity is 0. Then the series sigma minus 1 power n plus 1 an converges. N takes value 1 to infinity. So these two conditions are satisfied here. 1 is greater than or equal to half is greater than or equal to 1 by 4, etc. and limit of its nth term. See, the nth term is 1 over 2 power, 0, first power, second power, third power, and so on. So in general it may be an will be written as 1 upon 2 power n, and or 2 power n plus 1, and limit of this as n tends to infinity is 0. So the second condition satisfies, and therefore this is convergent. So this series is convergent. And the eighth is a simple example for limit. So here we can see whenever there are such type of functions or polynomials of n, then we can divide the numerator and denominator by the maximum power term from denominator, which is n square. So if we divide the numerator and denominator by n square, the limit can be written as it will be 3 n square minus divided by n square is 3 minus 6n divided by n square will be 6 by n, and denominator is 5 plus 4 by n square. And the limit of this is constant. So 3, we know the limit of 1 by n as n tends to infinity is 0. So therefore this term will be 0. Similarly, the denominator, this term's limit will be 0 because the denominator becomes infinite, the value approaches towards 0, and therefore the answer is 3 by 5. So this is the limit. And the next one is, if f of x is equal to 5, this is the function defined, then the function from R to R, real number to real number, is which type of function it is? 1 1 onto 1 1 and onto none of this. See, actually it is a constant function from set of real number to set of real number, and defined by f of x is equal to 5. That means all the points, real numbers from minus infinity to plus infinity are mapped to only single number 5. So all these will be mapped to 5 or has image 5. Infinite points are related to single point 5, and therefore obviously this function is not one to one, and the distinct elements have not distinct images. And see, what about onto? Onto the range, if the range is equal to the whole of real number, then it will be onto. Or for, so these are unrelated, these points of real line have no pre-image here, so therefore it is not onto. And this is not 1 1, this is not onto, this is not 1 1 and onto, and therefore the alternative is only none of these. So it is neither 1 1 nor onto. So these are some MCQs we have. We now consider the next questions. These are the next questions. Again, I will suggest you to first write your answers on a paper. Pause the video, write the answers on a paper, and then verify it. The next 10th question is the series sigma 1 over n 1 by n is. So what type of this series is? Convergent, divergent, conditionally convergent, absolutely convergent. So actually this is a theorem that we have studied. This is a harmonic series. Summation n takes value 1 to infinity 1 by n is harmonic series, and this series we have proved is divergent. So therefore the alternative for this series is divergent. Or actually we should see that this is a p series, summation 1 by n to the power p, as n takes value 1 to infinity, and this series is convergent if p is greater than 1 and for positive values, and if p is less than 1, less than or equal to 1, it is divergent. So this is p is greater than 1, then it is convergent, and if p is less than or equal to 1, then it is divergent. So this is the result to be remembered. And if the question is so for example, if you consider the series summation 1 upon n to the power 2, then this series is convergent, because here the power of n is 2. If the power of n is greater than 1, then the series is convergent, and but if it is less than or equal to 1, the series becomes divergent. So you should remember this result also. Summation 1 by n power p, so p series, p is greater than 1, then it is convergent, and p is less than 1, then it is divergent. So next question is, if f of x is equal to x square, function is given and its domain is minus infinity to plus infinity, then the range of this function is, which is the range? A's alternative is 0 to infinity, b is minus infinity to infinity, c is minus infinity to 0, and d is empty set. So this is a actually square function, and square of every real number is again positive. If the number is negative or positive, the square is always positive, and therefore this the range of this function will be 0 to infinity, and that means the correct alternative is A. 0 to infinity is the range. Next is every Cauchy sequence of real numbers is divergent, unbounded, convergent, and oscillatory. Cauchy sequence of real number is equivalent to convergent sequence. Cauchy and convergent are equivalent for real numbers sequences, and therefore the correct alternative is convergent. The series, this series is what type of series? Convergent, divergent, conditionally convergent, and none of these. So actually we have solved this as a problem in our earlier lectures, so you may refer that, and this series is convergent. It is convergent. So 1 upon 2 factorial, 1 upon 4 factorial, or in general 1 upon n factorial is less than this is 2 power n minus 1, and therefore the right side becomes a geometric sequence, and which is with the common ratio 1/2 less than 1, and therefore it is convergent, and therefore this series becomes convergent. The next is the sequence 1 plus 1 upon n plus 1 to the power n. Now we will consider it here separately. The limit of this sequence, limit n tends to infinity, 1 plus 1 upon n plus 1 to the power n, but to get the particular form we shall consider the power as reciprocal of this, but the original power is n, so we have to divide by the same term 1 plus 1 upon n plus 1. So this sequence is written in this form. See, the value is not changed. Here we have written n plus 1, and here we have written single term. So n plus 1 power and denominator is first power. So dividing this, we get the exact that term. And why we have written like this? Because the limit of the numerator is in the particular form 1 plus 1 by n to the power n, and that is equal to e. And the limit of the denominator is 1, this is constant, plus 1 upon n plus 1, n tends to infinity, this denominator becomes infinite, the value will be 0, and therefore it is e, and thus the alternative correct is B. The set of rational numbers is, and this is the result that we have studied, is which type of set? Uncountable, bounded, countable, and none of these. The set of rational numbers is countable. We have developed a scheme of counting the rational numbers, and therefore this set is countable. Now the next is, if f is function from a to b, x is subset of a, y is subset of a, then f of x union y is equal to. So actually this is a theorem we have proved, and this is f of x union f of y. So therefore the correct alternative is B. Next question, the set of rational numbers is. Now you see, for the set of real numbers, rational number is countable, but the set of irrational number is uncountable. It is a complementary function, a complementary set to rational number. So see, R is uncountable. The set of whole real numbers is uncountable, and the set of rational number Q is countable, and the set of irrational numbers will be equal to set of irrational numbers is equal to this is the complementary set of this countable minus this real numbers, rational numbers. Real number minus rational number is the irrational number set, and because this is uncountable, this set is uncountable, or this is complement of Q in R, complement of Q in R, and if Q is countable, its complement in R will be uncountable. So we have to remember, the set of rational number is countable, irrational number is uncountable, and whole real number is also uncountable. The last here we have written the 17th question, not the last, but 17th question is the sequence 10 power 7 divided by n has, what is the limit of this sequence, and this number 10 power 7, whatever it may be, is a finite number, and but the denominator becomes infinite, n takes value 1 to infinity, and whenever the denominator becomes infinite, the value approaches towards 0, and therefore the correct alternative is 0. So further we shall consider the next questions. These are the next multiple choice questions. First pause the video, note down the answers, and then verify. The 18th question is the series 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on is divergent, absolutely convergent, conditionally convergent, none of these. So certainly it is not divergent, because if we have this is alternating series actually, and by the theorem on alternating series, this is a decreasing sequence 1, 1 half, 1 by 3, 1 by n, or 1 by n is a non-increasing sequence, first condition, and limit of its nth term is 0. So therefore this is not divergent, but it is convergent. But here the option is not convergent, the options are absolutely convergent, conditionally convergent. We know when a series is said to be absolutely convergent if both summation an and summation of mod of an, or absolute value of an, convergent, then the series is said to be absolutely convergent. And but if you consider the absolute value, this is the sigma mod an, then each term becomes positive. The series becomes 1 plus 1 by 1 by 2 plus 1 by 3 plus 1 by 4, and in that case it becomes the harmonic series summation 1 by n, and which is divergent. So therefore this is not absolutely convergent, and now it is conditionally convergent, because this series is convergent but sigma mod of an is divergent. In such a series is said to be conditionally convergent. Therefore this is conditionally convergent. C is the correct alternative. And next is on characteristic function. Chi is the characteristic function on sets A and B. Then chi on the set A union B is equal to which of these values? Maximum of chi A and chi B, minimum of chi A and chi B, and C is 1 minus chi on A, and D is chi A minus chi B. So actually these are the properties of characteristic functions, and we should remember that chi of A union B is maximum of chi A and chi B, and chi on A intersection B is minimum of chi A and chi B. Chi of complement A is 1 minus chi A, and therefore the correct alternative is the first. It is maximum of chi A and chi B. 20th question is, if Sn is equal to minus 1 power n, then limit inferior of Sn is equal to which one? So limit inferior, see this is the alternating sequence, and the terms are minus 1 plus 1, again minus 1 plus 1, and so on. So therefore limit inferior of this sequence by definition is minus 1, and limit superior of this sequence will be plus 1. So therefore here the answer is D. Next is the graph of the function f is the subset of the Cartesian product of x and y, and is the set, which set, order pair set, is x f of x, x belongs to x, x comma x, again x belongs to x, f of x and x, x and x square. Now we consider the function fx, then we can write it as y is equal to f of x. And for plotting the function or plotting the graph of the function, we consider the values of order pair x and y. So therefore x is the abscissa or x coordinate, and y is f of x. So that means it is order pair x and f of x. So this is subset. Graph of function f is always subset of x, or it is a subset of the Cartesian product, and is actual set is x comma f of x, order pair. Next is all subsequences of a convergent sequence of real number converges to which alternative is there? Different limit, infinity, and the same limit, or 0. So we have actually a theorem. If a sequence is convergent, then all subsequences also converge to the same limit. So limit of a sequence cannot be different, and therefore the sequences, subsequences of this must converge to the same limit. The next is, if sigma ai, I takes value 1 to infinity, converges to s, that means this is the sum ai is equal to s, I takes value 1 to infinity. Then or actually this will be, that is a1 plus a2 plus a3 and so on is equal to s. Now what about the second series? It is sigma ai, I takes value 2 to infinity, and that will be summation ai, I taking value 2 to infinity. So it will start with a2 plus a3 plus a4 and so on, and therefore see this a1 will be shifted on this side, and then we will get these terms here. So therefore this will be s minus a1, and thus the alternative correct is C. Further, if sigma an converges but sigma mod of an diverges, then so we have seen this is actually the definition of conditional convergence and absolute convergence. So if this is convergent, but if you take the absolute value of each term, then the series becomes divergent, and such a type of series is said to be conditionally convergent. So therefore the alternative correct is D. And if both convergent, this also converges, then it is absolutely convergent. And the last one is if sigma an is convergent, then what about the limit of an? This is a theorem we have proved as first theorem on series. If this series sigma an of real numbers, infinite series of real number is convergent, then its limit of nth term as n tends to infinity is equal to 0. So therefore this is the correct alternative. So thus we have solved some of the multiple choice questions on the topics functions, sequences and series of real numbers. Thank you.